Right, chapter 8 is about equations. And equations is like chemistry shorthand. Instead of writing out everything that happens, we use symbols, we use formulas for compounds and stuff. It makes it just easier for us to deal with. Like I said, it's chemistry shorthand. Okay? So when we do an equation, we're representing a chemical reaction. And we do this to summarize what's happening. And when you do this, you have to tell everything that's happening. You can't leave stuff out, okay? Anything that's being reacted, anything that's being formed, you got to include it all, okay? And it also tells you specific amounts. We put numbers in front called coefficients, and it tells you how many moles of that substance we're going to use or how many moles of that substance we're going to produce. So again, equations are used to represent reactions. They tell you everything that you start with and you end with. Okay, when you look at a chemical equation, there's certain things. Okay, if we're looking here, these, what we start with in the blue here, these are called the reactants. They're like your ingredients. Okay, if I'm going to mix these things together, these are what I'm starting with. And these in front here are called coefficients. Coefficients are used to balance equations. We're going to talk about that. That's really important because when you have an equation, what you start with and what you end with, the total amounts have to be the same. Now you're going to end up with different substances, okay? They're going to combine and form different stuff. But the amount, like if I start with 50 grams of this and 50 grams of this, I might end up with 25 grams here, and then this would have to be 75. They have to be the same amounts, okay? So we use these numbers in front. Here they put letters. These are coefficients, and they're used to make sure that we have the same amount of stuff on both sides. Okay, so when you have a reaction, what you start with are your reactants. These are your ingredients. What you make are your products. So think of it as a recipe. You know, if I'm going to make cookies, here's all my ingredients I start with, and when I'm done, these are going to be my cookies. These are going to be my products. When you see an arrow like this, it breaks it into the two parts, reactants versus products. The arrow, actually, if you read it, would be yields or makes. So I would say A plus B yields C plus D. Okay? And again, they have to be balanced. Sorry, I'm cutting out my stuff here, but it says atoms balanced must be maintained in all chemical reactions. All atoms reactants must appear as part of the product. So what you start with here, like if you have hydrogen and oxygen, you better have hydrogen and oxygen over here. Things just don't disappear. Okay? All right, so the general structure of a chemical equation, again, we have our reactants. They're always on the left. That's what you start with. And your products are always on the right. And again, the arrow is what separates it, and the arrow means yields or makes. So these reactants make these products, or these reactants yield these products. Same thing. Okay? And then we use coefficients. Coefficients, we would substitute in here A, B, C, and D. Okay, they're used to balance equations. Okay, because remember I said we have to have the same amount of stuff on both sides. They're going to be combined with something different, but the overall amounts have to be the same. Okay, so we use coefficients. We put numbers in front, what they say, to balance the equations. And then numbers indicate how many moles of that substance we're going to have. Okay, we don't have to write ones. Okay, if you don't need more than 1 mole of that substance, you don't have to write a 1. But if you need 2 or 5 or 25, you have to put that number right here. Okay? Okay, so you don't have to write a 1, but you have to write the other ones. And the thing to remember is you're multiplying. Okay? You're not adding, you're multiplying when you put a number in front. Okay. The other things to remember is sometimes you'll have other little things about here, like this triangle up here means you have to add heat for this to happen. Okay, sometimes you'll see other things in there. There might be catalyst, there might be something else, but they just write that above there. Okay, so information about the reaction itself might be in there, but again, this is the most common, and that means added heat. Most of the time you won't see that, you guys. Okay, and then the one thing you'll see, and I won't write them when I write it out, sorry, because it takes a long time, is you'll see by them, you'll see little letters. Like if you see an S, that means it's phase. Its phase is a solid. L is a liquid. G is a gas. And then their AQ. AQ means it's dissolved in water. Excuse me. Okay? So when you see those little things by there, don't get confused. It's just telling you what phase they're in. And again, a common one that's kind of confusing is AQ. It means aqueous. It just means dissolved in water. So when you see those, you don't have to write them in when you write an equation. It's just telling you what phase they're in. Okay. All right, here they are summarized. Okay, again, the arrow means produces or makes or yields. We have solid, a liquid, a gas, AQ, a substance dissolved in water. An aqueous solution means dissolved in water. And then heat. So those are common symbols that you'll see in chemical equations. Okay, and then when we balance an equation, we have to follow this law. The law of conservation of mass says the total mass of substances in a chemical reaction remains constant. Okay, so when we look at our equations, our amounts have to be the same on both sides. We're going to have different substances. They're going to be a combination, like if we take hydrogen and oxygen and we make water, but we still have hydrogen and oxygen, and the amounts of hydrogen and oxygen have to be the same on both sides. So we balance the equations to satisfy the law of conservation of mass. Okay, here we got water. If we have 100 grams of water, okay, this is my reactant. And let's say I break it down into hydrogen and oxygen gas. Well, if there's, if we break these down, 11.2 and 88.8, we add these together, we get 100. They have to be the same. So the mass of the reactants and the mass of the products have to be the same. If they're not, then we have to balance our equation. And again, that's when we start using coefficients. These are little numbers that we put in front to help balance a reaction, okay? All right, balanced equations contain the same number of each atom on both sides of the equation. And again, that's to satisfy the law of mass. Okay, you can't make stuff disappear. You can't make something out of nothing. If you could make something out of a nothing, you'd be a bazillionaire. You'd be laughing at Bill Gates because you'd have more money than him. But it's impossible, so I guess we can't laugh at Bill Gates. Okay, so general. Okay, so here, if we're going to start from scratch, okay, we're going to have a word equation for reaction. We're going to say mercury 2 oxide yields mercury and oxygen. Okay, and we got a little heat symbol up here. Okay, so this is our first thing. Now what we have to do is change these words into symbols. Okay, mercury 2 oxide. Well, mercury is +2, oxygen's -2, so that'd just be HGO. Mercury is Hg. And then oxygen's one of those diatomics. Remember, there's 7 diatomic elements. When they're by themselves, when they're pure form, there's always 2 of them. And oxygen happens to be one of those. So we're going to rewrite them. Hg is mercury, oxide, like I said. This is 2 and this is 2, so it's just HGO. Remember, I told you, writing formulas, it's important stuff. We're going to use it over and over and over. Okay, and then mercury. All the elements except for those 7 that I talked about, when they're by themselves, they're just a single element, just Hg. But oxygen, is diatomic. So this, now I've rewritten it into symbols. Okay, now I need to balance it. Okay, if I look, I have 1 mercury right here. I have 1 mercury here, no problem. I have 1 oxygen, but here I have 2 oxygen. Now the only way to balance it, you guys cannot write a 2 here. Now you're changing this whole formula, and you can't do that. Don't ever change the subscripts, you guys, because you're either making compounds that don't exist, or you're making compounds that are different than what you actually have. Okay, so the only way you can balance them is put numbers in front. So I'm going to put a 2 here. That'll give me 2 oxygen. It'll also give me 2 mercury, so I'll put a 2 here. So by putting a 2 here and a 2 here, then I'm balancing my equation. Now, one thing you can do is you can write them out like this. You can see that they're not. I have 1 and 1, and over here I have 1 and 2. They're not balanced. So then you can do stuff to balance it. Some people need to do this. Most people don't. Okay, I'm not saying you have to do this. This is just something you can do. And you'll see here, by putting a 2 here, I still off here, so I need to add another 2. And this goes on and on and on and on and on. But really, here's your balanced equation. Okay, a 2 here and a 2 here balances it. And again, you can write out all the numbers if you want. You don't have to. Okay, I never do. But if that's the way for you to balance it, go for it. I'll put some YouTube videos that show you exactly how to do that. You can go through that if you want. And again, balancing equations, some people it's just a breeze. And some people struggle. So I'll have some extra videos for you to watch to help you with that. Okay? But again, by putting a 2 here and a 2 here, now I balance it. The last step in balancing an equation is to double check. And most people don't do this. But if I look, I have 2 mercury, I have 2 mercury. I have 2 oxygen. Anytime you put something in the front, you multiply that. I have 2 oxygen, I have 2 oxygen. My equation's balanced. Okay? And if you end up with 4 and 4 and 2, you guys reduce these to the smallest numbers. Okay, you always want the smallest whole numbers when you do a balanced equation. So what this is saying is I have 2 moles of mercury 2 oxide yields 2 moles of mercury and 1 mole of oxygen. Okay, so here we're going to do a chemical equation for magnesium metal undergoes combustion. Anytime something undergoes combustion means you add oxygen, and it produces magnesium oxide. So the word equation would be magnesium plus oxygen yields magnesium oxide. Okay, then we got to substitute. We got to put magnesium's Mg, oxygen's O2, it's one of those diatomic, and then magnesium oxide. Magnesium is +2 and oxygen's -2, so it's just MgO. But one thing I got to caution you, some of you guys will go, okay, it's O2 here, so I put O2 here. Not the case. You have to write your charges and balance them. Okay? You have to make sure that this is the proper formula for magnesium oxide. Just because it's 2 over here doesn't mean it's 2 over here. So make sure when you write a formula for a compound that you write the proper formula. That's why you still need to use that periodic chart I gave you with the ions on it. It's really important that you write the proper formulas, okay? So this is not balanced because I got 2 oxygen and over here I only have 1. So I'm going to have to balance my equation. So what am I going to do? I'm going to put a 2 here and a 2 here. And they're going to talk about all these numbers. And again, it might be a little overkill on that. Okay, so here. Sorry, I'm skipping over those, but honestly, I don't know that I need to go through all that. Okay, check to make sure. So 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen. So now I have a balanced equation. So this says 2 moles of magnesium and 1 mole of oxygen produces or yields or makes 2 moles of magnesium oxide. Okay? And again, you can put these numbers, you don't have to. Okay? If you really struggle with balanced equations, this might be a way to help, but it's not necessary. Okay? Here's another one. Potassium chlorate yields potassium chloride and oxygen. Okay? So this is what it's going to look like. This is potassium chlorate, and this is potassium chloride, and this is oxygen. Again, potassium's K, chlorine is Cl, 1 and 1. Chlorate is ClO3 and it's a -1, and potassium is +1. So I wrote everything out right. And again, oxygen's one of those diatomics. Now here's a problem. We have 3 oxygen here and 2 oxygen here. You can't just add a 1 here because you don't add them, you multiply them. So when you have that, you have to put a 3 here and a 2 here. Okay? So anytime 2 and 3, put a 3 and a 2. And then you'd have to end up balancing this by putting a 2. Okay? That's one, when you see the odd numbers like that, the only way to balance is put a 3 here, a 2 here, and now I have 2 potassium and 2 chlorine. I'm going to put 2 there. Okay? And again, it's going to go through all these. If you look here, I took care of the oxygen, but I still got to take care of this guy. So there's 2 potassium, 2 chlorine. I'm going to put a 2 there. Okay? All right, there we go. And again, you can look through this slideshow if you want every step by step, but I think it's kind of redundant. Sorry. All right. Anyway, now if I double check, I have 2 potassium. I have 2 potassium. I have 2 chlorine. I have 2 chlorine. And I have 2 times 3. I have 6 oxygen. 3 times 2 is 6 oxygen. Okay. So then it's balanced. Okay. Here's another one. Silver nitrate plus hydrogen sulfide, silver sulfide, and nitric acid. Nitric acid, you won't know, is HNO3. There's a 3 here, you guys, if you can't see it. Sorry. Okay. So I look and I've got them written out right. All right, now look, I got 1 silver, I got 2, so I'm going to put a 2 here. That'll take care of the silver. I have 2 silver, 2 nitrate groups, 2 hydrogen. Well, if I put a 2 here, that would give me 2 hydrogen and 2 nitrate. So I think a 2 there and a 2 there will take care of it. I'm going to go through these quickly because I'm running out of time. Sorry. Now am I balanced? Yep. So if you look here, 2 silver, 2 silver, 2 nitrate groups. When they stick together, you guys, you can just call them a group. So 2, you can say 2N and 6 oxygen if you want, but when they're a polyatomic ion and they're same on both sides, I just do them together. And then a 2 takes care of that. Okay, we're just about out of time. So that's where I'm going to end. And again, these, you guys, I'll put a YouTube video on how to do that. You do not have to do it if you don't want to. Okay, that's up to you, but always double check and make sure you've balanced it right.